Algebra 2, welcome back. Here's 6.3a. Okay, we're going to separate 6.3 into two sections. The first section is A, perform function operations. Okay, so our objective is to do exactly that. Perform the usual operations, addition, subtraction, multiplication, and division. There's no division symbol on my calculator or on my keyboard. On functions, okay? We normally do it on numbers, like 10 plus 5. But now we're going to do it on functions and see what that means, okay? So when we perform an operation on 2 or more, right, we can do, because sometimes we can do like 4 plus 5 plus 7, right? We can do it on multiple, we can do it on more than just 2 functions. Doing that creates a new function, okay? And these are the functions that get created. So we have the 4 operations. We have the addition function, okay, the subtraction function, the multiplication function, and the division function. Okay, and it's pretty self-explanatory. Whenever you see this, this means to take f of x and add it to g of x. Okay, this is just the name of it. Okay, these are the names of the functions, and these are the actual operations. This is what you do to get those functions. Okay, subtraction, that's just f of x minus g of x. Okay, multiplication, that's f of x times g of x. Okay, I'm not putting a dot here. I'm not going to do f dot g. The main reason why we're going to see in 6.3b. Okay, so you'll get to see why I'm not doing that in the next section, okay? Just know that the name of it is fg, not f dot g. You could, it's not a bad thing, but it's customary not to, and we'll find out in the next section, okay? And then f divided by g of x is f of x divided by g of x. And this one, remember, back from chapter 8, we want to make sure that our g of x is not 0. Otherwise, we get scary things, okay? So yeah, there's not much more to talk about in terms of learning how to do this aside from just let's do some examples, okay? So let f of x equal 5x and let g of x equal x plus 2. We're going to find all 4 of these operation functions using those f and g, okay? So let's start with the addition. Okay, f plus g of x. How do we find that? We just add the 2 functions. So that's going to be 5x plus, I'm going to put parentheses around it for good practice, x plus 2, because it's an entire thing, okay? But really, because it's addition, it's not going to change what I do. It's just going to be the same thing as 5x plus 2. Combine like terms, I get 6x plus 2. So this is my addition function. This is my answer to that, okay? Now let's do the subtraction function, f minus g of x. Okay, so that's going to be 5x minus, this is why I put parentheses on the first one. Good practice, right? Minus this whole quantity. So it's going to be minus x minus 2. I'm distributing that negative. So I get 5x minus x minus 2. This is 4x minus 2 is our answer here. Okay, make sure you use those parentheses, especially when the second one is a quantity, is like more than just one term. Okay, also understand that f minus g, because of the way subtraction works, f minus g will be different from g minus f, okay? 4 minus 2 is not the same thing as 2 minus 4, right? 4 minus 2 is 2, 2 minus 4 is negative 2. So just, that's kind of the explanation as to why they're different, okay? Multiplication function, so that's f times g of x. I do exactly that, 5x times x plus 2. Okay, here all we need to do is distribute because the first factor, the first function is just one term. 5x times x plus 2, that's going to give us 5x squared plus 10x. That is our multiplication function. Very nice. Okay, not too bad. And then al último, the last one is f divided by g of x. Okay, so 5x divided by x plus 2. Okay, and there's nothing more we can do here. We could technically, if you wanted to, if you think back to chapter 5, we can do log division or synthetic division, but there's not really a point to that. The only thing that would do for us is make it look different. But we're okay with it looking like this, like a rational function. Okay, so we're just gonna stop there with that one. Now, if we were to talk about the domain and extra stuff about these things, we would have to do a little bit more. But that's all we're gonna do for now. Just leave it as 5x over x plus 2, okay? So we're done with that example. Let's just keep practicing. It's all the same thing, okay? But let's just make sure we carefully read the instructions. So let f of x equals 6x and g of x equal x to the 3/4, okay? We're using our fractional exponents. We can have those in functions. They look pretty nice. We'll graph those in 6.5. Find f plus g of x, f minus g of x, f times g of x, and this is why we read the instructions. That one says g divided by f of x. Okay, so just kind of be careful there. All right, let's get to it. So f plus g of x is 6x plus x to the 3/4. Okay, remember this is going to be a radical. Okay, and even if we don't write it as a radical, can I combine those two things? No, because they're not like terms. Okay, one is just x. This one is the 4th root of x to the 3rd power, right? Remember that this can be written as 4th root of x, either the 3rd power here, or I can put it outside, whichever one, doesn't matter which one, right? Those are clearly not like terms, so we're just going to leave it as is. That is our addition function. Okay, that's all you got to do there. Same thing with the subtraction function. That one is even easier, or just as easy. 6x minus x to the 3/4. Cool. Forgot to change color there, but that's okay. Let's do the multiplication function. Here's where we can do it actually a little bit more. We have 6x times x to the 3/4. Okay, so the 6 is not like x and x to the 3/4. So the 6 is just going to carry down. But x times x to the 3/4, I can use my exponent properties. This is to the 1st power, same base. So what can I do? I can add the exponents. This is 1 plus 3/4. Okay, I need a common denominator. Okay, that's going to be 4/4. So 4/4 plus 3/4, that becomes 6x to the 7/4. Okay, so there's our multiplication function. And then lastly, our division function, g divided by f of x. Okay, g divided by f of x. What's my g? X to the 3/4. My f is 6x. Okay, same thing here. I can just kind of set the 6 to the side. That's going to be, we'll just leave the 6 there. And this is going to be x to the 3/4 divided by x. So that means 3/4 minus 1. Okay, so that becomes x over 6, but the x is to the 3/4 minus 1. That 6 still stays in the denominator, right? 3/4 minus 1, that's going to be 3/4 minus 4/4. 3 minus 4 is negative 1. So that's going to be x to the negative 1/4 over 6. But this is a negative exponent. We always want positive. So this is going to become 1 over 6x to the negative 1. Ooh, not negative, positive 1/4. Okay, so there's our division function. All right, and we'll do one last one, okay? Let f of x be negative 2x to the 2/3 and g of x equals 7x to the 2/3. Find f plus g of x, g minus f of x, g times f of x, and g over f of x, okay? So always paying attention to those directions. Maybe they'll change it up on us sometimes, and they did here. So f plus g of x. Wow, I kind of botched that whole thing, didn't I? A lot of little miswrites. F plus g of x, there we go, that looks a lot better. Negative 2x to the 2/3 plus 7x to the 2/3, okay? X to the 2/3, X to the 2/3, like terms, so I can add them. -2 plus 7 is 5, X to the 2/3. Okay, so there's our addition function. G minus F, okay, G minus F of X. That's going to be 7x to the 2/3 minus -2x to the 2/3. Okay, so that becomes plus, and they're still the same exponent, so I can add them. 7 plus 2 is 9x to the 2/3. Very nice. Forgot to change color again. Oh well. G times f of x. Multiplication doesn't matter, right? It's commutative, so I can multiply in whichever order I want. So that's going to be -2x to the 2/3 times 7x to the 2/3. Okay, multiply our like things together. -2 times 7, that's the -14. X, same base. That means I add the exponents. 2/3 plus 2/3 is 4/3. So there's our multiplication function. And then for the final ultimo one is g over f of x. Okay, g is 7x to the 2/3 divided by -2x to the 2/3. Okay, notice how these are the same. I can use my exponent properties here, but they're the same thing. So those just divide each other out and become 1. So I just get -7/2. I get a constant function, okay? Now, just like with the first division function we got on top, even though this looks pretty nice, when we graph it, there's going to be kind of some weird things with it, but we're not going to worry about that, okay? We're just going to worry about, can we perform these operations with our functions? Cool. That's all we have for this one, okay? I will see you in the next video, 6.3b, where we're going to talk about another operation we can do with functions, okay? Bye-bye.